Here's integrated 3. This is problem 9-114. It wants you to identify possible factors of this cubic here. So there's a little rule that says if you take the factors of the constant term, we're not very focused, factors of the constant term, which in this case is -15, and divide by the factors of the lead term, which is the term with the highest exponent, that in this case it's just 1, those will give you all your possible factors that would divide into the cubic. So the factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, and then the factors of the coefficient of the x cubed is just 1. So I know I can just look at the answer choices that they gave me, and so I've got a 1, so I like that one. 2 will never go into, 2 isn't on my list, so, and I'll show you why in a minute. So it's not letter B. Letter C, that's a 4, so that's not on my list, and I'll show you why that doesn't work. And then 3 is on my list. It doesn't matter if it's plus or minus. So the answer to problem 9-114 would be letter A and letter D, and then let me kind of explain why that's true. So if you were going to do some factoring here, we use the Polydoku area model and polynomial division. So you take the x cubed and you put it in the top left, right? And then these two, well, first of all, you have to have something to divide by. So you're going to have like x plus 1, or what if I tried to put something that doesn't go into 15, doesn't the -15 end up down here? So like I'm going to get some x squareds here, and they're going to add up to -5x squared. And then I'm going to end up with some x terms here, and the x terms are going to add up to 11. But then in the end, if it's actually a factor, we won't have a remainder. And this number here times this number here is going to multiply to make the -15. Well, you can imagine if I put a 2 here, what can I multiply 2 by to make -15? Well, the only thing, well, nothing, right? And what could a 4 won't work here because what 4 times what equals 15? So it can only be 1s, 3s, or 5s that might possibly work here. So hopefully that's a good enough explanation for that one.